The bisection method cuts the interval into half and disregards the irrelevant part. In this way, iteration will be faster. You are watching numerical solutions to C problems. Before delving with an example, let's differentiate bisection from the previous method first. Say that we have a curve drawn on the Cartesian plane, where the root is as indicated. When we were working on incremental search method, we actually have to divide the interval into desired increments and compute in order to know which smaller interval to use in the next iteration. Although admittedly, this method is simple, it is time-consuming, so the bisection method shortens the procedure a little bit. In this approach, the concept is to cut the interval into half and totally disregard the irrelevant half. So we take x of 0.5 and then drop the first half as the root is found on the second half anyway. Let's use bisection method to look for the root of the function twice of the cube of x less 1 minus 5x plus 6. The root is near 0 and it must be positive. The accuracy required for this problem is 3 decimals, and the initial values should be whole numbers. Just like the other methods, we determine the initial values by plugging in assumptions. These assumptions are based on the given requirement of near the origin and should be positive. So assume the initial limit as 0. Place this into the function to come up with 2 times the cube of 0 minus 1 less 5 times 0 plus 6. And this comes out as positive 4. Now let's try x of 1 into the function to have twice of the binomial 1 minus 1 cube less 5 of 1 plus 6, which turns out as positive 1. Since this is another positive, we take x of 2, the function becoming twice of 2 less 1 cube minus 5 times 2 plus 6, giving negative 2. With the sign jump, we already have the initial limits. Graphing what we just computed, at x equal to 1, y comes out as 1. When x is 2, y becomes negative 2. Joining these two coordinates, we can identify the root somewhere in the middle. To start with the bisection method, label the left limit as positive because its y is positive, and the right limit is negative. Then we verify which half to disregard. Take the midpoint by computing the average of the x values. That is half of 1 plus 2, giving 1.5. Use this result into the function to know the y-coordinate of the curve at midpoint. The function then is twice of the cube of 1.5 minus 1 less 5 times 1.5 plus 6. And this yields negative 1.25. By negative, it means that the negative limit is replaced by 1.5. So the right half is disregarded. We can use a table to iterate faster. The table has at least 5 columns for this method. The first is just to know the number of iterations consumed. There should be columns for the left and right limits, followed by the column for the average of A and B, which is term C. Then the column for the value when C is placed into the function. From the initial computations, A was 1 and B was 2. Take their average, which is 1.5, and write it under C. 1.5 is then placed into the function, giving negative 1.25. These values we computed earlier. With the first iteration completed, check the sign of f of c, which is negative. This means that c should replace b. That is, 1.5 is then the new b value, but a remains the same. Then take their average. Half of 1 plus 1.5 is 1.25. Plug this into the function to get twice of 1.25 less 1 cubed minus 5 of 1.25 plus 6. This results in negative 0.21875. Start the third iteration by identifying which should c replace. The current f of c is negative, which means 1.25 should replace b. Then a will still be 1. The average of these two columns is 1.125. Then plug this value into the function, making 2 times 1.125 less 1 cubed minus 5 times 1.125 plus 6, and get positive 0.37891. The third iteration is complete, although a long way to go to reach 3 decimal zeros. Do the same process for the next iteration. Since f of c is positive, 1.125 should be placed in a. Then b carries 1.25. Take the average of these two and have 1.1875. The function then becomes twice of the cube of 1.1875 minus 1 minus 5 of 1.1875 plus 6. F of c for this iteration is computed as positive 0.07568. Knowing that f of c is positive, this indicates that c replaces a, and b has the same value. Again, complete the table by solving for the midpoint, and that is half of 1.1875 plus 1.25, giving 1.21875. Then use this to solve the function, which turns out as negative 0.07281. With the latest f of c of negative 0.07281, we replace b with 1.21875. A remains the same at 1.1875. Take the average of the two columns. That's 1.1875 plus 1.21875 divided by 2, giving 1.20313. Have this substituted into the formula to have 0.00114. The seventh iteration will have a replaced by c because the current f of c is positive. B stays the same at 1.21875. Again, take the average of these two, that is 1.21094, and plug it into the function, making it twice of 1.21094 minus 1 cubed minus 5 of 1.21094 plus 6. The new f of c is negative 0.03593. There is an up and down trend of the f of c, but just the same, we keep on iterating until we can have 3 decimal zeros. With negative 0.03593, the value of c replaces b, and a of 1.20313 remains the same. Take their average, that is half of 1.20313 and 1.21094, yielding 1.20704. Place this into the function to have negative 0.01743. Moving on to the next iteration. With f of c turning out as negative, we replace b with 1.20704. A remains the same at 1.20313. Again, solve their average to have c. So half of 1.20313 plus 1.20794 gives 1.20509. Place this into the function and have 2 times the cube of 1.20509 minus 1 less 5 times 1.20509 plus 6, which turns out as negative 0.00817. Now we have another double decimal zeros. So continue iterating, where because of negative f of c, we place 1.20509 under b, and a remains the same. Again, take the midpoint, and that is with half of 1.20313 plus 1.20509, giving 1.20411. Place this into the function to come up with negative 0.00354. A trend is starting to appear as we are nearing zero in the accuracy. So continue with the next iteration. With the negative f of c, have 1.20411 replace b, while a is still 1.20313. Their midpoint is at 1.20362 after taking the average of columns A and B. The function then is substituted with 1.20362, where the result is negative 0.00122. So a trend is showing 3 iterations in a row already. Let's try our luck with this iteration. Having negative f of c, replace b with 1.20362. Then a is still 1.20313. Compute the midpoint. That's 1.20313 plus 1.20362 all over 2 to get 1.20338. Now plug this value into the function to get 2 times the cube of 1.20338 minus 1 less 5 of 1.20338 plus 6. The result is negative 0.000051. If this is rounded to the required accuracy, it will show 0.0001, which still conforms with the requirement. So we can say that the root is 1.20338.